properties of our exponents. I've crossed out scientific notation because I'm not going to cover scientific notation. You can do that in chemistry or in physics. There are 5 major rules for properties of exponents. There's a lot of wiggle room with how you use these properties. It's going to vary from question to question. Sometimes you can use different ones. Okay, so the work from person to person can vary a little bit. There's some flexibility. As long as you properly apply the rules, then it's not going to be an issue. So working on your homework while I'm teaching, focus on me. So our first one is our product rule. Okay, product means that we're doing what? Multiplication. Multiplication is repeated addition. Okay, multiplication and addition have a very close relationship. So when we're multiplying expressions with exponents, we can add the exponents together. Okay, but the bases have to be the same. Okay, the base of the exponent has to be the same. If it's a different base, then we can't add the exponents together. Same base, we can add them together. Okay? What I'm going to do is I'm going to expand this and show you why this works. Okay? 3 squared is 3 times 3. Right? Okay? What's 3 to the 4th? 3 times 3 times 3 times 3. Right? How many times am I multiplying 3's together? 6 times. I'm multiplying 3's 6 times. Well, what is 4 plus 2? 3 to the 6. Okay? That repeated multiplication just gets added together. So when we're adding exponents with the same base, then we'll go ahead and multiply or add the exponents together. So on B, do all of those have the same base? Yes. So I can just add my exponents together. So Z, 3 plus 2 plus 5 equals Z to the 10. Okay? Now, with C, I've got coefficients and I've got variables. Multiplication, commutative property multiplication says I can multiply in any order. So I can rearrange that so I have similar things grouped together. So I can group my coefficients and my variables. And then do the part. What's 3 times negative 4? Negative 12. So that gives me negative 12. And then if I have y squared and y to the 4th, what times y to the 4th, what am I going to do with those exponents? Add them together. Add the 2 and the 4, so I get negative 12y to the 6th. Multiply your coefficients, add your exponents. Notice for 3y squared, only the y is being squared, not the 3. Only the y is being raised to the 4th power, not the negative 4. Okay, so where the location of that exponent is going to be really important that you pay attention. It's a lot of attention to detail. Okay, slight changes that can result in a different answer. Okay, product rule, add our exponents. Product rule, add our exponents. Zero exponent rule. Zero exponent rule is my favorite because it's the easiest. Anything raised to the 0 power always equals 1. Anything raised to the 0 power always equals 1. And I'm going to show you why on the next slide because it's an extension of our quotient rule. Okay? But it's a nice, easy rule to remember. Anything to the 0 power always equals 1. The only exception to that is 0 to the 0 power. 0 to the 0 power is undefined. Again, because it's an extension of our quotient rule. So, 5 to the 0 power, 1. Negative 5 to the 0 power, negative 1. This is basically negative 1 times 5 to the 0 power. Okay, that negative isn't being raised to that exponent, so it's not going to end up being a positive 1. It's going to be negative times 1. Okay, so I got a negative 1. This entire expression is being raised to the 0 power, so it equals what? 1. And then I have negative x to the 0 power. Negative 1 again. Okay? Again, it's attention to detail. All right? If I had that negative x in parentheses, and the negative was being included with that 0 power, then yeah, absolutely, it would be a positive one. Paying attention to the location of that exponent is going to make a big difference. Product rule says we do what again? Add. And our 0 exponent is 1. Quotient rule. So product rule says we add. Quotient is division, so we're going to subtract the exponents. Product rule is add the exponents. Quotient rule is subtract the exponents. All right? Again, we have to make sure the bases are the same. So I have x over x, x to the 12 minus 9, which is what? X to the power of what? 3. Looking at b, I got to make sure I just do my division with wherever the bases are the same. So 9 over 3, the coefficients, just divide those as normal. Simplify that. What's 9 over 3? 3. Okay? So that just becomes 3. And then I have a to the 4th minus... Hold on, I'm still on the a's. If I don't have an exponent here, what do I assume it is? A 1. Okay? There's no exponent listed. It's assumed to be a 1. So I'm going to do a to the 4 minus 1 times b to the 7 minus 2. And then we can simplify that. A to the what? And b to the... Good. 3a cubed b to the 5th. Power product rule is to... Product rule is to... What's our product rule again? Add. 0 exponent equals 1. Quotient rule. Subtract. Negative exponents. Our key word there is going to be, if I have a negative exponent, I write the base as its reciprocal, and then make the exponent positive. I write the base as its reciprocal, and I make the exponent positive. So, what's the base for a? 3. What's the reciprocal of 3? 1 over 3. The reciprocal of 3 is 1 over 3, and then the exponent becomes positive. Okay? Now, this says simplify and write with positive exponents only. If it just says to simplify, then we need to take this a step further and actually square the 3. Note the difference there. If it just says to simplify, it doesn't specify write with positive exponents, then we need to actually continue and square the 3. So sometimes if you get this and you're like, why did I get that wrong? Then you might need to take it a step further. And actually square. B. What's being raised to the negative 4th power? Just x. And only x. So what's the reciprocal of x? That's the opposite. What's the reciprocal?
1 over x.
1 over x. So 2 doesn't change. 2 stays a 2. And now I have it multiplied by 1 over x to the 4th. And then when I simplify that, what do I end up with? 2 over x to the 4th. If that was in... That's a simple one. Because 2 is not being raised to that power, so 2 is just 2. Now, let's expand on that. There's a little bit of variation once we start adding in some more complex expressions. David, whatever you're doing is definitely not more important than what I'm doing right now. Guaranteed. You have a little bit of variation in what rules you can apply. So the best advice I can give you is when you start getting more and more complicated expressions with more and more factors in them and more exponents, is pick a rule and use it. Rewrite it, okay? Use that rule so it simplifies your expression, and then look at it again and see what the next rule you can do is. How can you simplify it again? Because it may take 2 or 3 or 4 or 5 steps. Pick a rule, simplify it, check it again, and repeat the process until all your coefficients are simplified. You only got a variable that shows up once. Okay, each variable only shows up once. All right, and none of your exponents are negative. Okay, there's a couple different ways I could approach this question. I could use my quotient rule, or I could use my negative exponent rule. Okay, I could do either one. To start, it's going to get me to the same destination. But I want to show you something with negative exponent rules that makes it a little bit easier. Okay, so fractions are what operation? When I have a fraction, what operation am I doing? Division, right? So I have 7p to the 8th divided by p to the negative 2, right? So if I have 7p to the 8th divided by p to the negative 2, all right? Using my negative exponent, how do I simplify p to the negative 2? I'm just simplifying this right here. Reciprocal. 7p to the 8th divided by 1 over p squared. Well, now I'm doing division with a fraction. What's the process for dividing with a fraction? Subtraction. Multiply by what?
By reciprocal.
By the reciprocal again. Whenever you have a fraction, like 1/2 divided by 1/4, right? We multiply by the reciprocal. We do 1/2 times 4 over 1. Keep change flip. Multiply by the reciprocal. It's the same process here. That negative exponent made me write it as a reciprocal, but now I have a fraction with division. So then I need to go ahead and write it as its reciprocal again. So I end up with 7p to the 8th times p squared, which I can simplify. So what happened with that p to the negative 2 from here to here? And made it positive, and then put it where? In the numerator. If you have a negative exponent in a denominator, make it positive, move it to the numerator. If you have a negative exponent in the numerator, make it positive and move it to the denominator. So that negative exponent, when we write the reciprocal, it just moves it from one side of that fraction bar to the other. That's all that this work proves. That exponent rule. We're just moving it from one side of the bar to the other and making it positive. So using my negative exponent rule to clean this up, get rid of that, get rid of that, get rid of that, is just taking this exponent, moving it up here, and writing it as 7p to the 8th times p squared. And now I can use my product rule, which says I do what? So I end up with 7p to the 10th. Okay? So using my negative exponent rule, I get 7p to the 10th. And I can do that in 2 steps. Here, and then here. Quotient rule says I do what? Subtract. Quotient rule says I'm going to subtract. So I've got p to the 8th minus negative 2, which equals 7p to the 10th. 2 different processes, same result. So you have a little bit of flexibility. Simplify it and keep going. So I have negative exponent rule, I've got quotient rule, product rule. Depending on how I approach B, I've got a couple options. So pick a rule. Pick a rule to simplify B. Quotient rule? Okay. What am I going to use the quotient rule with? Okay. Which ones?
So we subtract 5 minus.
Not on the coefficients. Coefficients is just normal division.
Alright, then you would do negative 9.
Yep. So, quotient rule here. X, negative 9, minus 1. Alright?
And then 4 minus.
I can do it again with the y's. Y to the 4 minus negative 2. And then 5 over 10, just simplify it. What's 5 over 10 simplify to be?
1/2.
1/2. 1/2. Okay? So we simplify that. I end up with 1/2 times x to the what?
Negative 10.
Negative 10 times y to the 6. To subtract exponents. So negative 9 minus 1 for the x's. 4 minus negative 2 for the y's. And then I just simplified it by doing the actual subtraction. Negative 9 minus 1 is negative 4 minus negative 2 is 6. Nope, not done yet, because do I have only positive exponents?
No, you got
So now I use the negative exponent rule.
Therefore, would you multiply by 5?
I would write the base as its reciprocal. For x. Yep. So I have 1/2 times 1 over x to the 10 times 6 y to the 6. And so now I need to just clean that all up. So I'm multiplying all those together. I don't have negative exponents anymore. I've only got one variable showing up each variable showing up once. All my coefficients are simplified. So now, just multiply. Let's do that. Okay? So write that as a fraction. Multiply your numerators, multiply your denominators. What's 1 times 1 times y to the 6?
Y to the 6.
Y to the 6. What's 2 times x to the 10th times 1? X to the 10th. Good. Simplify your coefficients. Each variable should only show up once. No negative exponents. That's it. Now tomorrow, Monday, the next day, we're going to add in another rule, and then we're going to look at a little bit more complex exponential expressions. But again, it all boils down to pick a rule, simplify it, and then check again and keep going. You don't have to do it all in one go. Some of them are really simple and it only takes one step. But once you start to get expressions like these, well then I need to start seeing the work. Okay? Questions, comments, concerns, queries, or conundrums? Because most of them are real quick. Most of them take like